my name is Bill Dietrich. I've been a professor at Berkeley since 1982, and I've done lots of different kinds of projects in the general field of geomorphology. So I'm interested in landslides and river channel processes and floodplains and all these sort of things, soil formation, soil transport, and trying to discover the physical processes that shape the Earth. I've been working on monitoring water movement through hillsides for nearly 30 years, outside, going out and putting instrumentation in the ground, wells, piezometers, devices to measure moisture content, rainfall. And we call it a field experiment because we try to at least monitor things well and capture what happens in individual rainstorms. But we're always stuck with nature being the heterogeneous, unpredictable way it is. And we always have surprises. And here, you're going to have total control. You're putting the material you want, you're going to put the rain you want on, you're going to have sensors everywhere. And what I think will be the most exciting part will be the surprise. Despite your efforts, good efforts to monitor everything, I think probably the most exciting and what will be most interesting, the things that happen that you didn't anticipate, that you could only find out by doing this kind of work. By having what you think is total control, and by seeing something happen, you can actually know why it happened. So often in the field, something happens we don't know, we can't explain it. Here, if you get the surprise, you have a good chance of knowing why it happened, and then ask the question, how does that translate back out in the field where we have a lot less knowledge about what's going on our sites. So here you probably be able to interact with your surprise, and that something will happen and say, well, now I can change something and explore that and tease it and figure out what's going on. And then you have such a strong team of modelers, they can take that back to the modeler and say, okay, what are we missing that we can't explain with the model, that will then improve the model, and then hopefully tell us who are out in the field what additional measurements to make better measurements, to get better explanation, to get better forecasts of what comes in the future. So that's one thing that I find very appealing about this, is this sense of being able to explain a discovery, to explain a surprise. It's that sense of interaction that's so hard to do in the field that you can do here that really is one of the great opportunities here, I think.